Hi everyone, I'm going to discuss solving systems of linear equations in two variables using the elimination method and substitution. So let's start with the elimination method. So when we say elimination method, our goal is to eliminate one variable and we come up with an equation with one variable. So that would be easier for us to solve for that variable. So once we have the one known variable, we can solve for the other variable also by substituting the value of the known variable in either of the equations. Okay, so we can use addition or subtraction in eliminating a variable. Take note that we use addition if to cancel the variable if the coefficients of the variable are the additive inverse of each other. On the other hand, we use subtraction if the coefficients of the variable are exactly the same. So in this example, we can use either addition or subtraction. Like if we want to eliminate y first, we will use addition because the coefficients of y here are exactly the additive inverse of each other. While if you opt to use subtraction to eliminate one variable, or to eliminate x. So that's possible because the coefficients of x here are exactly the same. So the difference of exactly the same value equals 0. So that would lead to cancellation of the variable. So for example here, if we're going to use addition, so x plus x is 2x, and then negative y plus y is 0. So that's why variables y are cancelled, and then negative 6 plus 8 is 2. And then we will solve, or we can solve for one variable, which is x here. So divide both sides by 2 and x equals 1 now. Now with x equals 1, we will substitute x equals 1 to either of the equations. Okay. So for example, if we use the first, if we substitute x equals 1 to the first equation, so we have 1 minus y equals negative 6. So transposing negative y on the other side and negative 6 on the other side also, we have 1 plus 6 equals y. So y equals 7. Okay? So we now have 1, 7 as the solution for this equation or system of linear equation. Now, this 1, 7 should satisfy both equations. So we have to check and substitute 1, 7, which is the value of x and y respectively, to both equations. Like using the first equation, substituting 1 and 7 to the x and the y, we have 1 minus 7. Is it equal to negative 6? So really negative 6 equals negative 6. How about the second equation? 1 plus 7 equals 8. So 8 equals 8. So really, the solution for this system is 1, 7 because this solution satisfies both equations here. Now, in number 2 class, I suggest that we use subtraction for us to eliminate y. Now, if you want to eliminate x, it would be more complicated to do so since the coefficients of x here are neither exactly the same nor additive inverse of each other. So what we will do for us to eliminate x is to rename each equation here. While if we're going to eliminate y here by just using the operation subtraction, we can right away eliminate y. Now, in subtraction, we have to recall the rule that we have to change the sign of each of the term of the subtrahend. So this negative becomes positive, this becomes negative, and positive 2 becomes negative 2, and then shift to addition. So this is like 2x plus 3x. So we have 5x here. Y plus negative y is 0. And 12 plus negative 2 is like 12 minus 2. So we go back with subtraction. So this is 10. And then we can solve for x now by dividing both sides by 5. So we have x equals 2. So now we will substitute x equals to either of the equations. Okay? And if we're going to make use of the second equation, like we will substitute x equals to the second equation here, and this is the first equation. So we have negative 3 times 2 plus y equals 2. So we have negative 6 plus y equals 2. Transpose negative 6 on the other side of the equation, we have y equals 8. So the solution class for this system is 2, 8. So we have to verify if the solution 2, 8 satisfies both equation. So substitute 2 and 8 to the x and the y respectively of each of the equations. So let's begin with the first equation. 2 times 2 plus 8, is it equal to 12? So we have 4 plus 8 equals 12. So really 12 equals 12. How about the second equation? Negative 3 times 2 plus 8 equals 2. So this is negative 6 plus 8 equals 2. So we have 2 really equals 2. So this satisfies both equations here. So more examples using elimination method. So here, in either of the variables class, um, there is no equal coefficients as well as additive inverses of each other. So what we're going to do is to rename the first equation if we want to eliminate y, like we will make the coefficient of y equal to 2 or negative 2. Now, if we opt or if we choose to make use of addition as the operation in eliminating y, so we have to make the value of y equal to negative 2. So we will multiply each of the terms here by negative 2. So we have negative 4x minus 2y equals negative 14. And then we will rewrite the second equation here. So we have 5x plus 2y equals 16. And then we will perform addition. So negative 4x plus 5x is x. And we know that negative 2y plus 2y is 0. Then negative 14 plus 16 is 2. So x equals 2. So the next thing that we're going to do is substitute x equals to either of the equations. Okay? So if we're going to make use of the first equation and substitute x equals 2, so we have 2 times 2 plus y equals 7. So we have 4 plus y equals 7. Transpose 4 on the other side. So we have y equals 3. So the solution then is 2, 3. Now, 2, 3 should satisfy both equations. So we have to check and substitute x equals 2 and y equals 3 to both equations. So let's begin with the first equation. So we have 2 times 2 plus 3. Is it equal to 7? So 4 plus 3 equals 7. Therefore, 7 equals 7. And then second equation, 5 times 2 plus 2 times 3. Is it 16? So this is 10 plus 6 equals 16. So 16 equals 16. So correct. So 2, 3 is the solution for this system. Okay. Now here, we can, it's very convenient to use addition and eliminate x since the coefficients of x here in the first and in the second equation are the negative or the additive inverse of each other. So we will use addition, and negative 2x plus 2x is 0. And then 3y plus 5y is 8y. Negative 1 plus 25 is 24. Solve for y by dividing both sides by 8. So y equals 3. So if y equals 3, then substitute y equals 3 to either of the equations to solve for the other variable x. So to either of the equations. So if we're going to use the first equation, so we have negative 2x plus 3 times 3 equals negative 1. So negative 2x plus 9 equals negative 1. So negative 2x transpose 9 on the other side. So this is 1. I'm sorry. Okay. So this is negative 10. Negative 1 minus 9. Okay. So divide both sides by negative 2. So x is 5. Now, the solution here would be 5, 3. So we have to check if the solution satisfies both equations. So with the first equation, we have negative 2 times 5 plus 3 times 3. Is it equal to negative 1? So this is negative 10 plus 9 equals negative 1. So negative 1 equals negative 1. And for the second equation, 2 times 5 plus 5 times 3 equals 25. So this is 10 plus 15 equals 25. So 25 equals 25 plus. So this satisfies both equations here. So we can say that this is the solution for this consistent and independent system. So that's how we solve for the system using elimination. This time, I'm going to introduce substitution method. And these are the steps. One is we have to solve one equation for one equation of the variables. So we're going to choose in either equation which variable are we going to solve in terms of the other variable. And then we will substitute the result in to the other equation. And then we will solve for that resulting equation. As we solve for that equation, take note that we will come up with solving one variable now. And then we're going to find the corresponding value of the other variable. And the last thing, same thing with elimination method, we will check by substituting the values obtained in the original equations. So solve for the system using substitution here. Now, we're going to rename the first equation and solve for the value of y. So, this is step 1. Solve one equation for one of the variables. Okay, and we're going to use equation 1 here. Now, it would be better if we transpose negative y on the other side to isolate y, and then this constant term transpose on this side also. So we have 2x minus 9 equals y. Therefore, class y equals 2x minus 9. So we have solved for one variable of equation 1 in terms of the other variable. In fact, y equals 2x minus 9. This time, we'll do the second method. We will substitute y equals 2x minus 9 to the other equation. Since we have majors of equation 1, we will substitute this to equation 2 here. This is equation 2. So instead of writing y, this one, we will replace this by 2x minus 9. So we have 3x minus 4 times 2x minus 9 equals negative 24. And then as you can see, we are now in step 3. We will solve for the resulting equation and take note that we're only dealing with one variable here. Okay? So we can solve for this variable. And this is 3x minus 8x. Is it right? 3x minus 4. Okay. So this is 8x plus 36 equals negative 24. And we know that 3x minus 8x is negative 5x. And then negative 24, we will transpose this on the other side. So this is minus 36 now. So negative 5x class equals negative 60. So divide both sides by negative 5. We have x equals 12. Same with what we did in the elimination process. We will substitute x equals 12 to either of the equations. Okay? So if we prefer the first equation, so this is 2 times 12 minus y equals 9. So we have 24 minus y equals 9. So we have 24 minus 9 equals y. So y equals 15 here. So the solution for this system is 12, 15. Again, we have to check if 12, 15 satisfies both equations. So let's begin with the first equation. So substitute 12 to x. So we have 12 and 15 to y. Will the left side equals the right side? So this is 24 minus 15. And really 9 equals 9. How about the second equation? So we have 3 times 12 minus 4 times 15. Is it equal to negative 24? 36 minus um 60. Is it equal to negative 24? And really, negative 24 equals negative 24. So the solution 1215 satisfies both equation. And we have made use of substitution this time. Okay, so how about here? So we have 1 half x minus y equals 3. Now, it would be easier for us if we solve for x here in terms of y. And this will be our x. And we will substitute the value of x, which is 6 plus 2y, to the x of the first equation. So this is our first equation, second equation. So we will substitute x equals 6 plus 2y to equation 1. So we have 1 half times 6 plus 2y plus 2y. So this is 1 half x. So instead of writing x, we replace that by 6 plus 2y. And then minus y equals 3. Now, for us to simplify this equation and to come up with the denominator 1, we will multiply each term here by 2. Okay? So this will be canceled. And we have the first term equal to 6 plus 2y. And then negative y times 2, this is minus 2y. 3 times 2, this is 6. So simplifying the expression, so the variable y was canceled. And we come up with the left side equal to the right side of the equation. In this event class, since the variable is canceled, now the system is either inconsistent or consistent and dependent. Since we come up with equal values on both sides, then we consider that the system is consistent and dependent. Thus, the solution set class is infinite. Now, really, the system is consistent and dependent because the two equations also are equivalent. Now, if we're going to rename this one and multiply each of the expression by 1/2, we will be leading to the same equation of equation 2. So this is really consistent and dependent. Now, in the event class that the variables are canceled and we come up with the left side not equal to the right side, the system instead is called as inconsistent, and the solution must be an empty set. Okay? So next, we can simplify the or we can solve for y of equation 1 here by transposing y on the other side and 7 on the other side as well. So we have 2x minus 7 equals y. So y equals 2x minus 7. Okay? And we will substitute class this y equals 2x minus 7. This is equation 1. This is our equation 2. To equation 2. Instead of writing y, we will replace that by 2x minus 7. Okay? So we have 5x plus 2 times y. So this is 2x minus 7. And then equals 16. And then solve for the equation. Take note again that we come up with one variable only, and that's variable x. And we will solve for x here. So we have 5x plus 4x minus 14 equals 16. Okay? So we have, oh, from here, 2x minus y equals 2x minus 7 equals y. So this is correct, but this has to be negative. So I think let us go back with this one. Wait, guys. So let's go back with simplifying the first equation. Okay. So we have I think we just have to transpose 2x on the other side. So we have y equals negative 2x plus 7. And then we will substitute y equals negative 2x plus 7 to equation 2. Okay? So instead of writing y here, we're going to replace this by negative 2x plus 7. So we have 5x plus 2 times quantity negative 2x plus 7 equals 16. Okay, so we have 5x minus 4x plus 14 equals 16. So 5x minus 4x is x. And then we'll transpose this on the other side. We have 16 minus 14. So x is 2. So we will substitute x equals 2 to either of the equations. Okay? So if we use 1, so we have 2 times 2 plus y equals 7. So we have 4 plus y equals 7. So y equals 7 minus 4, which is 3. So the solution, class, is 2, 3. Okay? If you remember, we have made use of this as our example in using elimination method, and we still come up with the same solution 2, 3. So just check out how we substituted 2, 3 to both equations, and 2, 3 really satisfies both equations. So the solution must be equal to 2, 3. So whether we use elimination or substitution as method in solving for the solutions for the systems of linear equations in two variables, we should come up with the same correct solution. So that's it for now.